Hey everyone, this is Neha and we are back with episode 2 of building your own options trading platform on Aptos Move. So in episode 1, we basically discovered a little bit more about what options are, what are call options, what are put options. And now that we have that understanding all set, we are ready to write our options.move smart contract. So if you look over here, we have our VS Code screen ready. And we have just set up our developer environment. So on the left panel, if you see, you can see script sources, all of these different folders. If you don't know how to set up your development setup on Aptos Move, I will link up the video above for you to go and check that out. And then once you're at the same screen as me, we can get started with writing our smart contract. So if you have checked out the previous Aptos Move coding tutorials, you would have the understanding of how we go about writing our code here. So first of all, we need to write the module keyword followed by the deployer's address here. And then we can name this options. This deployer underscore address is something that we need to set in our move.toml file. So I'll just add this over here and just setting this for now. Okay, so we have our deployer address over here followed by options as the name of our module. And the structure that this will take is, well, so these are going to be our use statements where we'll be like importing a couple of different things. This will be followed by some constants. This can include error codes and otherwise. This will be followed by our resources and objects, followed by our event structs, and then our functions. We can keep our entry functions at first and then moving to the view functions. And then you can maybe write down some tests. So this is going to be more or less the different things and the order in which will work. So for today's episode, we will just be focusing on the import statements, constants, and a little bit on the resource objects and initializing our contract bit. So let's get started. Okay, so the import statements, we will be importing a couple of different things. From our STD libraries, I'll be taking signer and error. We have vector, we have debug to print. So this is all the things that we can probably take from the standard library. If we need something more, we can import it later. And then we need to import a bunch of things from the Aptos framework. We will be working with the object library a lot. So we can take object, we can take a couple of references that we'll be using here like delete ref, extend ref, transfer ref, object as well actually. Yeah, so this is a couple of things that we'll be using. We will also need events. So just gonna go ahead and copy that as well. Events, then let's get coin, Aptos coin as well. So this is gonna be Aptos coin, timestamp because options, so we will be needing that. And what else do we need? We've got object, event, coin, Aptos coin, timestamp. We can also possibly get account. I think these import statements are good for now. We will also need to import some statements for our Oracle stuff, but we can add them later as and when we get to it. So these are a couple of import statements that we'll be using. Now, let's first start off with discussing the different possibilities of errors that can happen in this particular application, and then we can start writing the different possible codes as well. So moving on to the resources and objects bit of it, I think this is the part which is very important and interesting to see how the different data structures work here. So primarily we will be dealing with 3 different objects here. The first is the OptionsConfig, which will be set by the deployer address and which is responsible for setting some configuration and maintaining the list of all of the options created. So you can think of it as an options list along with some config items as well. Second, we will have our OptionDetail struct. This will basically be created by the creator, and this will be responsible for saving all of the different details. So this will have things like the premium associated, the amount associated, the ID, expiry timestamp, and a few more items. And the third would be our OptionVault, which will just have our funds, just a coin, Aptos coin. That's all. So these are the different structs that we'll be dealing with. Along with this, we'll have some events. Events can be on a couple of different things, but primarily whenever an option is created, when an option is bought, when an option is exercised, and when the option is settled. So this can have a couple of different events that we can basically invoke whenever these things happen. In this particular episode, we'll just talk about the init module function, we'll just kick off creating the options config. In the next video, we'll go into the deeper functions of creating the options, buying the options, exercising, settling, all of that. But this has made one thing clear to us before we go ahead. In our constants, we can actually add a constant to maintain the option state. So we can keep this as something like active. We can just keep this as U8 and we can keep this as 0. And we can have state exercise, state settled, state, and we can just give them difference over here. Perfect. So this will be basically the details for all of the states for our options. Okay, so now let's actually go ahead and define our struct over here for options config, detail, and vault. So I'm just gonna say something like struct options config has key. I'm saving a bunch of different things here. An admin address. This is going to be the address for the deployer here. We want to keep basically a track of all of the different options which have been created. So we can just maintain the number of options which has been created. So we have an options created one and options addresses. So all of these individual options are actually objects which are stored as options detail objects, as we'll see below. So we can just maintain them as a vector list of addresses. Perfect. And then because this is the config object, we also need to save a couple of details about what kind of config we need to keep for the option. So here we can set a minimum expiry in seconds and a maximum expiry in seconds. So for every option that is about to be created, we can check whether it falls in the range as dictated here. And this will just be another U64. Great. And if we want to basically extend this particular or modify this particular options config, we can save an extend ref over here, which will just be of extend ref type, which we have inherited from here. Great. So this is the rough options config that we have. Now let's go ahead and define our options detail now. Options detail. So for options detail, we will be saving a couple of different things. First is the ID associated with the options, the creator address, premium, which will be some amount which we can save as a U64, the expiry timestamp, which can again be a U64. We need to save the options type, which will be a U8, and this will be 0 for call and 1 for put. And we can actually add this here as well, just like we did for this. So we can just say call option and put option. Great. Okay. And along with this, we can save the state as well. So option state, which will again take a U8. We also need to save the strike price. When this option can be exercised, we can save this as a U64. And in order to actually transfer or delete this particular options detail, we can add a delete ref and a transfer ref. Okay, so we have our delete ref and our transfer ref added here. We also need to add a creation timestamp here. So in order to measure the difference between the creation and expiry, great. So this is our rough struct options detail over here. Now our struct options vault will just carry the funds. So it's pretty straightforward. We can just do a funds and we can maintain coin, Aptos coin. Okay, this is going to be capital C. That's the one that we have imported. Okay, and now we want to save all of these three as objects. We will basically add this particular pound symbol modifier at the top, which says that these are resource group members. Framework object group. And that's the way we can basically just signal that this is an object. So I'll go ahead and add this here and here. Great. So now we have our different structs, different objects set over here, options config, options detailed, and options vault. So now that we have the objects out of the way, we can actually go ahead and write our init module function, which will be executed whenever this contract is deployed. The event structs and a couple of different things, we can add them later when we go deeper into the other functions. So let's start with our init module. So this will just be entry fun init module. And the signer here can just be the deployer. So I'm just going to say deployer as the signer. Now, in this particular function, I just want to create our options config object, which will be created by this deployer address. So let's first get this deployer address by using our signer library. So we just need to do a deployer address, signer address off, and pass our deployer over here. Then let's go ahead and actually create a named object. So named objects are non-deletable objects, and these objects allow simple indexing as well, because you can basically derive their address easily by passing the address and any associated name that they have with it. So here we will add a name in our const to actually differentiate this particular named object. So I can just say something like const name, which we can save as a U8 vector, which will take b string of OptionsConfig object. Yep. So now we can just go ahead and create this particular object. So whenever this object is created, the function actually gives back the constructor reference. So we can just say something like constructor ref is equals to this function is present within the object library. So I'm just going to say object create named object. First parameter is going to be our signer and second parameter is going to be the name. Yeah, this is just giving the constructor ref. We can generate our extend ref, which will be saving in this particular object as we saw earlier by doing let extend ref is equals to object generate extend. My bad, I just saved that as an admin, my bad. Generate extend ref, and here we'll just pass our constructor ref. Great. So now using this, we have generated our extend ref as well. Now let's generate an object signer. So let object signer is equals to object generate signer, and we can again pass the constructor ref over here. And now that we have our object signer, we can create or complete OptionsConfig object and move this under our object signer. So we can write something like move _to object _signer, and this is going to be an OptionsConfig object, which will take a couple of different things. So first we have our extend ref, which will just be an extend ref, admin, which will take our deployer address, options created 0, options addresses. So this will be vector empty for address, and then we have our minimum expiry in seconds and maximum expiry in seconds. So we can keep the minimum expiry to be, maybe we can keep this to be 10 minutes. So this will be 600. And the maximum expiry, we can keep this to be maybe 1 hour. These are just for testing purposes. You can actually make it way more longer than this. And here this, we just need to add the 7%. Let's just open the terminal and try to compile the code that we have so far. Aptos move compile. Awesome. So the code is compiling as expected. So this is episode 2. In the next video, we are going to actually start writing the different functions for creating the options, buying the options, exercising the options, blah, blah, blah. We'll be adding events, and we'll also be introducing the concept of oracles and how we can use oracles with Aptos Move. Stay tuned for the next episode. See you. Bye-bye. And as well as we'll look into our main init model function and how the whole flow would work. If you want these videos to keep coming, don't forget to like, share, and subscribe. I'm super excited for this one. Let's get right into it.